Okay, let's simplify a complex fraction. So if I look here, I'm looking at this algebraic expression and going, oh, don't like it. I agree, but it's okay. If you look, you have a fraction, you have another fraction, and then you have the fraction bar between them, which means division. So all a complex fraction means is two fractions are on top of each other, connected by division. Well, we know dividing fractions easy as pie, flip this second and multiply. So we know automatically to work this, to simplify this expression, we're going to have to rewrite it as multiplication. So the first fraction we leave the same, x squared plus 7x plus 10 over x squared minus 4. Now I'm going to multiply by the reciprocal, the multiplicative inverse of the bottom fraction. So the 2x plus 4 will go in the numerator, and the x squared plus 2x minus 15 would go in the denominator. So that's all we're doing. Nothing more difficult than that. Once we write it horizontally, we're back to our beginning modules. Multiplying fractions is no problem. Top times top, bottom times bottom. Do you really want to multiply a trinomial times a binomial? No way. So the song says, before you start to multiply, factor first, then divide. We are not connected anywhere by multiplication. So we need our rules of factoring. So here we go, ladies and gentlemen. Does x squared plus 7x plus 10 have a GCF? Nope. There's three terms here, so this is a good old trinomial rule. So I'll put my two parentheses. It's an easy trinomial. What can multiply to x squared? Only x times x. Now I go to 10. My factors of 10 are 1 and 10, 2 and 5. What factors will multiply to 10 and add to 7? Well, that will be the 2 and the 5. Adding means the signs have to be the same. Add to a positive. They're both positive. All right, let's go to the denominator. The denominator is x squared minus 4. Do you have a GCF? Nope. That is a difference of perfect squares. So I'll put my two parentheses and write my conjugates. X squared is x times x. 4 is 2 times 2. 1 gets a plus, 1 gets a minus. Beautiful. Go to the next fraction. Same thing. 2x plus 4. That has a GCF. I can divide each term by 2. So I pull out a 2. I'm left with x plus 2. All right? Denominator. There is no GCF. This is a good old trinomial. It's easy. So I'll put my two sets of parentheses. Get a different color. There we go. X squared is x times x. 15 is 1 times 15, 3 times 5, correct? I want to subtract to make 2. It'd have to be the 3 and the 5. I said subtract, so the signs have to be different. The sign in the middle is a positive 2, so that goes to 5, the positive number, the larger number. And the 3 gets a negative. Everybody's good? So now that I have my expressions in factored form, here we go. Let's cancel away. Do we have the same terms we could divide out? I see an x plus 2 and an x plus 2. Those binomials are the same. I see an x plus 5 and an x plus 5. Those binomials are the same. Now I see an x plus 2 and an x minus 2. They're not the same. What are these binomials called? Very good. They're conjugates. They have the same terms, 2 and x. The middle symbol's different. We've discussed this. Can you reduce conjugates? No. So we're stuck with them. And we have a 2 and an x minus 3. They're not the same. So we've done all the reducing we can do. So now we'll multiply across. So in the numerator, we have a 2 times x plus 2. And in the denominator, we have x minus 2 times x minus 3. Now, if this was me and it was my class, I would accept this. Sometimes, though, your instructors want you to go all the way, and they want you to multiply that out. So just to review, if I multiply my numerator, I would distribute. 2 times x is 2x. 2 times 2 is 4. If I multiply my denominator, it's a binomial times a binomial, so I'm going to do FOIL. First is x times x, which is x squared. Outers are negative 3x. Inners are negative 2x. Well, a negative 3x and a negative 2x would add to negative 5x. Last would be negative 2 times negative 3, which is positive 6. This fraction is equivalent to this fraction. It just depends on your author of your textbook and your professor which method, which form they prefer the answer in. I prefer the factored form. Some professors want you to simplify it out. But that's all there is to working a complex fraction. All we're doing is using everything you've learned. Okay, see you in the next module.